Engineering. This is the first semester, Anna University Tripoli. Fundamentals of Electrical and Electronics Engineering lecture notes we can discuss today. So first part, basic principles of electricity. So this is a fundamental concept, right? First of all, we know everything about the atom and charge. Then only we can study about electricity. So can you saw the diagram? Actually, this is a helium atom. Helium atom contains, okay, electron and proton, neutron also. So electron around the proton, right? So the red color indicates a proton, white color indicates a neutron, right? Okay. So electron is assumed to be negatively charged and proton is assumed to be positively charged. So this is the way of how the bonding between electron and proton, right? So electron is assumed to be negatively charged and proton is assumed to be positively charged. Now we can study the definition for electrical charge. So unit of electrical charge is coulomb. That means 6.3 into 10 raised to 18 electrons. That will be equal to 1 coulombs, right? That means electric charge per electron. That will be 1 by 6.3 into 10 raised to 18 coulombs. Look at that, a bowl contains of lots of charges are there, right? This is a definition for charge. It indicates Q, capital Q, or otherwise Q of T. Why? We can say it will be varying depend upon the time. Whenever the time changes, the charge also changes, right? So mostly electric circuits are used to move charges at desired rates through the circuit elements. One is motion of charge, another one is a separation of charge. The motion of charge is nothing but the electric fluid. Okay, suppose consider one charge will be moved means that is equivalent to electric fluid, right? It is a current and the separation of charge. So the separation of charge is nothing but electric force in terms of, we can say, voltage. In conventional general, what happened? Positive charge moves to the negative charge, right? The mechanical analog, we can saw that we can force the ball, okay, at the ground level. It indicates H1, right? And it will be moved in upward direction. That's the final height. That will be H2. The variations between both height, okay, the difference between the heights, we can say del H. Upper level, right? Consider from H1 to H2. That means lower to upper, we give the. Consider when the ball reaches the upper level. Suppose we do not give any force, but due to the gravitational force, it moves towards a lower level, right? That's an inclined surface. Suppose it is okay. So from the lower pressure to higher pressure, okay, the pressure will be marked in P1, the upper side marked at P2. the variation of the pressures. Okay, the difference between the pressure P2 minus P1. Okay, when it reach the upper part, what happens? Suppose the tap will be open, means automatically what happens? The water flows. That is due to the gravitational force. Water flowing from higher to lower potential. Similarly, electric potential difference in the sense of, so negative side we can mark as potential V1, positive side we can indicates V2, the current flow through the consumer. Okay. So electrons flowing from always higher to lower potential. Here positive in the sense of we can consider this is a higher potential, right? Now we can use a each concept. Ground node, okay. So the fundamentals will be used for solve the problems very easier manner. That's why I discussed here, okay. So ground node is the point, right? Ground node is a point. That means it is a junction, okay. In junction, we can assume there is no voltage, okay. Assume there is no voltage. All other voltage take their reference with respect to their ground node, okay. So represent like that in the this this is a symbol for the ground node, okay. Consider the right side diagram. One voltage source is there, one load is there. The current will be passes from, already we told, na, higher potential to lower potential. Okay, consider positive side higher potential and negative sides negative side lower potential. So the difference between the voltage del V, that is equal to nothing but the higher potential minus lower potential, right? So now we can consider that will be a ground. V1 should be a ground. Na? So V1 ground in the sense of the voltage level 0. Clear? So how much the potential difference between that? There is a difference is higher potential only. Because ground, okay, the ground node is considered about 0. Ground node is nothing but the earth point. Okay, ground node is nothing but the earth point. Actually, we connect the multimeter, the common point. Consider it is a common point, na? Like that. So the ground node is a point at which the voltage assumed to be 0. Okay. So ground node, black terminal. Measured node, that is a red terminal. Right? Now we can study the definition for the current. Okay. It indicates capital I. Definitely, we can say it's also varying upon the time. So I of t, that means time varying in the sense, we can say t, I of t. Current is nothing but the time rate of change of charges. In particular variation of time, in particular changes of the charges also there. Consider one charge in one particular position, it will be, suppose it may be increase or decrease. Okay, depend upon the time, right? So the differentiations with respect to time. Okay. So unit of current is nothing but ampere. It will be indicated capital A. 1 ampere, that is will be equal to 1 coulomb per second. 1 ampere is nothing but 1 coulomb per second. So current has a magnitude value. Okay. Magnitude is nothing but we can say that numerical value 1 ampere, 10 ampere. No? That's why it has a magnitude and it has the directions also. Okay. like that. The mark I in right away now. So that's having a direction value. So total charge entering the element between time t1 and t2. Total charge entering the element between time t1 and t2. Suppose how much the charge will be there. We want to calculate. No? So the total charge Q is nothing but the integrations of a current, okay, with respect to time. So the upper limit is t2, lower limit is t1, I into differentiation of tau. Okay, so now what happened, it will be in terms of charge na? So q of t2 minus q of t1, right? So consider the current definition for both AC as well as DC, right? In direct current DC, it depends upon that straight line, okay? Sorry, not it depends upon time, na? That will be marked in a straight line. Alternating current in the sense of it will be vary on time to time, will be pulsating, okay? So next one, example, consider 1 meter conductor, okay, 2 mm diameter in the sense of a cylindrical conductor is 1 meter long and 2 mm in a diameter, and it contains 10 raised to 29 free carriers per cubic meter. Now we want to find the total charge of the carriers in this wire. Second one, if the wire is used in a circuit, find the current flowing in the wire if the average velocity of the carrier is 19.9 into 10 raised to minus 6 meters per second. So now we want to solve now. In order to compute the total charge contributed by the electrons, we first need to compute the volume of the conductor. So volume, that is equal to length into cross-sectional area. We know the formula, okay? How much length and how much area we have, that we can multiply, we get the volume. So length marked by L, it is a circular shape now. So area formula is nothing but pi r square. So pi r square into L. So we know the value of R. Okay, R how much? Here the radius is not given directly. They given the diameter only. We know the formula diameter d, that R that is equal to d by 2. Okay, here diameter is 2 millimeter na. So 2 into 10 raised to minus 3 divided by 2, because they given in the diameter, we in this formula radius only there. Okay, so apply the diameter value, and the formula is pi r squared, so we can square the value. And the length, we know that 1 meter length, so we can put the value of 1. So pi into 2 into 10 raised to minus 3, the minus 3 divided by 2, the whole square. Next, we compute the charge by determining the total number of charge carriers in the conductor as follows. So charge, that is equal to nothing but volume into charge per unit volume. Actually, volume, we know that the last step, na? We can pi into 2 into 10 raised to minus 3 with respect to 2, the whole raised to 2 into 1 into charge. How much charge they given in the problem? Already they mentioned, right? So minus 1.602 into 10 raised to minus 19 coulomb. Okay, divided by they given 10 raised to 29. So carriers with respect to meter cube. Okay. So now we can put all the values in calculator. We get the answer is negative answer. Okay, minus 50.33 10 raised to 3 coulomb. And the second case, If the carriers move with an average velocity of 19.9 into 10 raised to minus 6 meter per second, the magnitude of the total current flow in the wire can be computed by considering the current is the flow of charge per unit time. So current is nothing but the charge density per unit length into carrier velocity. So charge we find out now. So 50.33 into 10 raised to 3 divided by 1 into carrier velocity already they mentioned. Okay, average velocity they given in the problem now 19.9 into 10 raised to minus 6. So we get the answer is 1 ampere. Okay, approximately it will be 1 ampere. Okay, thank you, students. We can study the next topic in next session. Thank you.